Hello students. Today we are going to start with the second part of Maths 2, chapter number 5, quadrilaterals, in which we are going to deal with the practice set 5.43 and 5.4 and the theorems related to it. So let's begin. Very first theorem, diagonals of a rectangle are congruent. So first we have to consider the rectangle ABCD we have considered ABCD, in which AC and BD are the diagonal, and we have to prove that they are equal. That to prove is diagonal AC is equal to diagonal BD. And what is given to us? Given part is quadrilateral ABCD is a rectangle. Okay. So here we begin with the proof. Now here we have to consider two triangles. So I'll just write the triangles over, draw the triangles over here of quadrilateral ABCD. So here it is A, B and C, and where this angle is 90 degree, and here is another triangle, that is D, C and B, where C is the right angle. Now here AB and DC are the parts of the rectangle. Okay, so AB is equal to CD or DC, that is opposite angles, opposite sides of rectangle. Okay, after that angle ABC, this angle ABC is equal to angle DCB. Okay, each 90 degree, and this BC is the common base over here. Okay, so BC is equal to BC common side. So these two triangles are equal to each other by which test? By SAS test, right? So now by SAS test the two triangles are equal means all the parts of the triangles will be equal to each other. So AC is equal to BD. That is, diagonal AC is equal to diagonal BD. So here we have completed first proof of this video. So here we have to prove diagonals of the rhombus are perpendicular bisector of each other. What is given to us? EFGH is the rhombus that is given to us. What we have to prove? We have to prove that EG is perpendicular bisector of HF and HF is perpendicular bisector of EG. This we have to prove as they are diagonals of one another. Now we start with a proof. Now your EF is equal to FG and FG is equal to GH and GH is equal to HE. Okay. They are the sides of rhombus and all sides of rhombus are equal to each other. So E and F are equidistant from the end points. E and F are equidistant from the end points. E and G are the equidistance from endpoint F and H. Okay, of line segment FH. Why? Because the sides are equal. So if you draw the line in between, it will be equidistant from the given line. Okay, so E and G is point E and G lies on the perpendicular bisector of FH. Why? Because only one and one line can pass through two distinct points. Okay, only one and one line can pass through two distinct points, and every segment has one and only one perpendicular bisector. So diagonal EG is perpendicular bisector of diagonal HF. Similarly, we can prove that HF is the perpendicular bisector of EG. Now, how you are going to prove that? First, we have to say that point H and F are equidistant from end points of E and G of segment EG. So, H and F lies on the perpendicular bisector of segment EG. As such, why? Because only one and one line can pass through two distinct points and every segment has only one perpendicular bisector. I hope I am clear. Now we move on to the next one. Now here we start with the first exercise, that is exercise number 5.3 of that first problem. Diagonals of rectangle ABCD intersect at point O. This is ABCD rectangle in which diagonals intersect each other at point O. Okay, now BO is given to us. This BO is given to us. Sorry, BO is not given to us, AC is given to us. Here AC is given to us and we are supposed to find BO. Then angle CAD is given to us as 35 degree and we are supposed to calculate angle ACB. Okay, now here AC is 8 centimeter, right? Now AC is equal to BD. Why? Because diagonals of rectangle are congruent, right? So what will be the length of BD? Length of BD will also be equal to 8. Now BO is half of BD, right? Why? Because diagonals bisect each other in rectangle. Okay, so now substitute the value of BD. What is the value of BD? It is 8. So BO is equal to half of 8. This BO is equal to half of 8. Therefore value of BO is 4 centimeter. Right till here? Understood? Now the second part of it. In second part, AD is parallel to BC and we will consider AC as the transversal. Okay. Now just work on the line DAC is equal to ACB. Now DAC is equal to ACB means they are alternate angles. The lines are parallel and the transversal Z is forming over there. So it is they are alternate angles and alternate angles are always congruent. So one of the angle is given, that is angle DAC is given to us as 35. So angle ACB will also be equal to 35 degree. This was the first problem. Now we move on to the second problem of it. In a rhombus PQRS, if PQ is equal to 7.5 centimeter, then find QR. If angle QPS is 75, then the measure of angle PQR and find the measure of angle PQR and angle SRQ. Okay. Now here, what is given to us? PQRS. PQRS is a rhombus. This is given to us. Length of PQ is given to us as 7.5. So what will be length of QR? It will be 7.5 only. Why? Because sides of the rhombus are equal. All four sides are equal to one another. Even if anybody asks you what is the length of RS, so it will be 7.5 centimeter. Length of PS will also be equal to 7.5 centimeter. Okay. Now we have been given the measure of angle QPS and we have to find out the measure of angle PQR. Okay. Now as these lines are parallel to each other, okay, so which angle is forming over here? They are forming means it is as such that they form the interior angles, right? Adjacent angles are supplementary. So angle PQR plus angle QPS is equal to 180 degree. Substitute the value of angle PQR. So angle PQR QPS you have to substitute. So it is 75 plus angle PQR equal to 180 degree. Angle PQR is equal to 180 minus 75. So measure of angle PQR equal to 105 degree. Okay. As angle PQR is 105 degree, measure of angle SRQ is equal to measure of angle QPS. Angle QPS is 75, so this angle will also be 75. Therefore, measure of angle SRQ is 75 degree. Third problem, the diagonal of the square IJKL intersect each other at point M. Okay. Now here, find the measure of angle IMJ. 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 Measure of angle JI. Sorry, JIK, and measure of angle L LJK. Okay. So here, what is given to us? That IJKL is the square. IJKL is a square. This is given to us, right? So here, measure of angle IMJ. IMJ will be equal to 90 degree. Why? Because the diagonals of the square are perpendicular to each other, right? So measure of angle IMG is 90 degree. Then diagonals of the square bisect opposite angle. Okay. Now measure of angle of square is 90 degree. So half of 90 degree will be equal to 45 degree. So measure of angle JIK and measure of angle LJK will be equal to 45 degree. Okay. Next problem. Diagonals of rhombus are 20 centimeter and 21 centimeter. Then find the sides of the rhombus and its perimeter. Okay. Now we know that the diagonals of rhombus bisect each other and are perpendicular bisector of each other. So measure of one of the means, suppose a diagonal is given to us as 20. Okay. So ABCD is the rhombus in which BD and AC are the diagonals. Okay, so BD is 20 and BC is sorry, AC is 20 and BD is 21. So half of AC will give me AO and half of BD will give me BO, right? So half of AC is equal to half of 20, that is equal to 10 centimeter. Okay, and half of BD is equal to half of 21, that is equal to 10.5 centimeter. Now here the angle so forming over here is right angle triangle, as angle AOB is 90 degree. This angle AOB is 90 degree. Therefore, it is a right angle triangle. Fine. Now we have to apply which theorem? We have to apply Pythagoras theorem. So 10 square plus 10.5 square will give me AB square. Okay. So AB square is equal to 100 plus 110.25. So AB square is equal to 210.25. Now AB square is 210.25. So what will be AB? AB will be equal to 14.5 centimeter. Sides of rhombus are 14.5 centimeter. What will be the perimeter? All four sides are equal. So it is 4 into side. So that is equal to 4 into 14.5, that is equal to 58 centimeter. So length of the side is 14.5 centimeter and perimeter of rhombus is 58 centimeter. Now the last question of this exercise, state with the reason whether the following statements are true or false. Every parallelogram is a rhombus. Now in rhombus all sides are equal, but in parallelogram opposite sides are equal. So the given statement is false, right? Now the second one, in second one every rhombus is a rectangle. Now in a rhombus, in a rectangle all angles are 90 degree, but in rhombus it is not necessary that all angles are 90 degree. Okay, and in rectangle also opposite sides are equal, but in rhombus all sides are equal. That's why the given statement, that is every rhombus is a rectangle, is wrong. Okay, the next one is next one is every rectangle is a rhombus, is a parallelogram. So it is a true statement. Why? Because Uh, in rectangle, opposite sides are parallel. In rhombus, opposite sides are parallel. So the rectangle can be a parallelogram, but the parallelogram need not be a rectangle. Okay. The next one, every square is a rectangle. Now here, this is a true statement. Every square is a rectangle. In a rectangle, all angles are 90 degree. In square also, all angles are 90 degree. In a rectangle, opposite sides are equal. In square also, if we consider the opposite side, they will be equal only. Okay. So now every square is a rhombus. It is true. Why? Because in rhombus all sides are equal, and in rhombus also, in square also all sides are equal, as in rhombus all sides are equal. Okay. Now the last one, every parallelogram is a rectangle. Now it is false, as I have already stated this one, that in a quadrilateral is a rectangle if all its angle are 90 degree, but in parallelogram it may not be necessary. Okay, therefore every parallelogram is not a rectangle. Now we move on to the next topic of the chapter, in which we are going to discuss about trapezium. Now, when one pair of opposite side is parallel, then the given quadrilateral is known as trapezium. Now, here AB is parallel to DC. Okay, these two are parallel sides, and AD is not parallel to BC. Then this quadrilateral ABCD is known as trapezium. Okay. Now here, one of the properties there of parallel lines, in which angle A plus angle D is 180 degree, and angle B plus angle C is 180 degree. Okay. Now isosceles trapezium, one more concept is there, in which if the base angles are equal, suppose angle B is equal to angle C, then the given trapezium is known as isosceles trapezium. Okay. Now median of trapezium, if I draw a line passing through the center of non-parallel lines, okay, this red line, okay, so here, and if I name this as P and this is Q, so AP is equal to PB, and DQ is equal to QC. Okay, so the segment joining the midpoints of non-parallel side of the trapezium is known as median of the trapezium. Okay, now P and Q are non-parallel. P and Q are the midpoints of non-parallel side AB and DC. The trapezium ABCD of trapezium ABCD respectively. Therefore, PQ is the median of the trapezium. Now, problems based on it we are going to discuss now. Okay. So the very first problem of it is quadrilateral IJKL. IJ is parallel to KL. Okay. Angle I is given to us as 108 and angle K is given to us as 53. We are supposed to find the measure of angle J and angle L. Okay, now the sum of these two angles is 180 degree. So 108 plus L equal to 180 degree. Angle L equal to 180 degree. Now what will be the measure of angle L? Measure of angle L will be 180 minus 108, that is equal to 72 degree. Next one also in the similar manner, 180 minus 53 you get the answer as equal to 127. Very simple problems. It is just based on your practice. The more you practice, the more clear your idea becomes. Now we are on question number 2 of practice set 5.4. In a quadrilateral ABCD, side BC is parallel to side AD, and AB is equal to DC, means it is which trapezium? It is an isosceles trapezium. Okay, and what we have to do, we have to prove that angle ABC is equal to angle DCB. Angle ACB is equal to angle DCB. This angles we have to prove that they are equal. Okay. Now here what is given to us, what we have to do, very first thing, we have to draw the perpendicular to line segment AD. So this BM is the perpendicular, okay, to AD such that M lies between A and D. Then CN is the perpendicular to AD such that N lies between A and D. Okay. This is what we have to draw. Fine. Now here BC is parallel to AD. As BC is parallel to AD, distance between these two will be equal. So from this we conclude that BM is equal to CN. Okay. So in triangle BMA and triangle CND, angle BMA is equal to angle CND, each 90 degree. Okay. Now hypotenuse B is equal to hypotenuse CD. It is already given to us. Okay. And BM is equal to CN. We have shown in equation number 1 why it is equal. Okay. So these two triangles are equal to each other by hypotenuse side test. Okay. As by hypotenuse side test they are equal. So measure of angle BAD is equal to measure of angle CDA. Okay. So measure angle BAD is 72. So what will be the measure of angle CDA? It will be 72. Base angles it's given. So this will also be 72. So angle D is 72. Right. So what will be the measure of angle ABC? Measure of angle ABC. So it is 180 minus 72. I have told you property of parallel lines. The same you have to use. So 180 minus 72 will give me the measure of angle ABC, that is equal to 108. Similarly, measure of angle ACD will also be equal to ABD will also be equal to 108. Okay. Now here we move on to the next problem, in which last problem of the exercise, in which quadrilateral ABCD is a trapezium, right? BC is parallel to AD. BC is greater than AD, okay? And BC is parallel to AD. If BA is equal to CD, then prove that angle ABC is equal to angle DCB. Okay. So here we have to again draw the perpendiculars. Perpendiculars are equidistant, so BM will be equal to CN, right? We have two triangles over here, so two triangles are equal. After two angles are equal 90 degree, same line we have to go. So two triangles will be equal by which test? By hypotenuse side test. From here we come to the conclusion that BAM is equal to angle CDN. This BAM is equal to angle CDN, right? Now as they are equal, now we have to move on to the next part of it. Corresponding next part is angle BAD is equal to angle CDA. BAD is equal to angle CDA, right? The same thing, but we have extended the line segment. Okay. Now BC is parallel to AD. So angle ABC plus angle BAD will be equal to 180 degree. Now BC is again parallel to AD and CD is the transversal. So angle DCB plus angle CDA is equal to 180 degree, 90 interior angles they are. Okay, as it is 180 and 180, so these two equations will be equal, so we will equalize both the equations. So your angle ABC plus angle BAD plus is equal to angle DCB plus angle CDA. Now your angle BAD is equal to angle CDA, so in place of BAD I can substitute CDA. So angle ABC plus angle CDA is equal to angle DCB plus angle CDA from equation number 2. So these two angles get cancelled over here. We are left with angle ABC is equal to angle DCB. So here we end up with exercise 5.4 over here. I hope you all have understood. Thank you.